Hi everyone, I'm Aria, an electrical tutor working with EWRB. Today I would like to start this audio review question series to go together with the audiobook based on the EWRB Electrician teaching guidelines. Please listen to the audiobook first, then use this audio review to test your understanding. Let's get started. Hi everyone, I'm Aria. Let's start our topic review. Before we begin, I just want to mention one thing. These review questions may contain mistakes. If you notice any mistakes, please point them out in the comments. I will double check them. If anything is corrected or updated, I will add the fixed questions in the video description below this video. So, when you listen to this audiobook, please check the description first. Thank you. Now, let's start. Topic 17: Switchboards and Isolation Devices. Review Question 1. In as NZS 3000 terms, what best describes a switchboard? Option A: only a single main switch in a box. Option B: an assembly of switching and protective devices, bus bars and wiring for distributing electricity. Option C: a portable test instrument for checking circuits. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option B. A switchboard is the organized panel that contains devices like circuit breakers, fuses, meters, bus bars, and the internal connections. Its job is to receive supply and distribute it safely to submains and final subcircuits, while allowing protection and isolation where needed. Review Question 2. What is the main purpose of a main switchboard? Option A: it supplies only one lighting circuit. Option B: it is the primary board that controls the incoming supply and provides the main point of isolation for the whole installation. Option C: it is used only for temporary building sites. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option B. The main switchboard is where the incoming supply arrives and where the installation can be isolated as a whole. Because it is the main control point, it must meet stricter safety requirements for access, barriers, labeling, and fault rating. Review Question 3. What best describes switchgear? Option A: any electrical cable used in an installation. Option B: equipment used to control, switch, protect, or isolate electrical energy, including breakers, fuses, isolators, and contactors. Option C: only the bus bar supports inside the board. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option B. Switchgear is the working hardware that does the switching and protection. It includes devices that turn circuits on and off, isolate them for work, and disconnect faults quickly to prevent danger or damage. Review Question 4. Which statement best links the terms correctly? Option A: the switchboard is the cabinet. Switchgear is the equipment inside that switches/protects. Option B: switchgear is the cabinet, the switchboard is one breaker. Option C: a main switchboard is always smaller than a distribution switchboard. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option A. The switchboard is the complete assembly and layout. The switchgear is the collection of devices inside that provide switching, protection, and isolation. Review Question 5. Why do main switchboards usually need the highest fault rating in an installation? Option A: because they are always outdoors. Option B: because they are closest to the incoming supply and can see the highest prospective short-circuit current. Option C: because they only supply low current lighting circuits. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option B. Fault current is usually highest near the supply source. The main board must withstand and safely control the worst-case fault level until the protective device operates, so ratings in construction are more critical. Review Question 6. What is a key special feature of a MEN switchboard compared with other boards? Option A: it contains the MEN link and the main earthing arrangements. Option B: it must never have any labels. Option C: it cannot contain any protective devices. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option A. A MEN switchboard has extra responsibilities because it includes the main earthing connection and the main earth neutral link, MEN link. That link is central to the protection system, so it must be installed correctly, clearly identified, and accessible for inspection. Review question 7. What does the MEN link do in simple terms? Option A. It disconnects the earth during faults. Option B. It provides the connection point between the neutral bar and the earth bar at the MEN switchboard. Option C. It increases voltage to improve motor starting. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option B. The MEN link bonds neutral to earth at the correct point in the installation. This supports a low-resistance fault path so protective devices can operate quickly under earth faults. Review question 8. Why must earthing and bonding connections at the MEN switchboard be low resistance and secure? Option A. To make meters read higher. Option B. Because earth fault loop impedance depends on that path, and high resistance can stop protective devices tripping within the required time. Option C. To reduce the color fading of labels. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option B. If connections are loose, corroded, or undersized, loop impedance rises. Higher impedance reduces fault current, which can delay or prevent disconnection. That increases shock and fire risk, and it can make the installation non-compliant. Review question 9. Which board is often also called a subboard? Option A. A distribution switchboard. Option B. A generator control panel. Option C. A test bench. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option A. A distribution switchboard is supplied from the main board and distributes power to circuits within part of the installation. It still needs correct protection, segregation, labeling, and safe access. Review question 10. Which is a correct requirement for safe access to a switchboard? Option A. Access can be cramped as long as the door opens. Option B. Access must allow safe operation, testing, resetting, and maintenance without unnecessary risk. Option C. Access is only needed during installation, not later. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option B. Electricians must be able to work safely at the board, operate switches, replace fuses, test circuits, and maintain equipment. Poor access increases the chance of contact with live parts, slips, trips, and rushed unsafe work. Review question 11. What is a correct location requirement for a switchboard? Option A. It can be installed anywhere as long as it is painted. Option B. It should be secure, kept dry, and protected from hazards and unsuitable environments. Option C. It must always be installed in a bathroom for convenience. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option B. Location matters because moisture, corrosion, dust, heat, and physical damage can reduce insulation and reliability. A good location supports safe access and reduces the chance of faults and deterioration over time. Review question 12. Why do switchboards sometimes need fire barriers or compartment separation? Option A. To make the board heavier. Option B. To help prevent the spread of fire from a fault within the board. Option C. To reduce voltage drop in cables. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option B. Faults can produce arcing and hot gases. Fire-resistant materials and separation can slow down flame spread and protect escape routes and adjacent areas, improving overall building safety. Review question 13. What does environmental suitability mainly refer to for switchboards? Option A. The color of the enclosure. Option B. Conditions like dust, moisture, chemicals, heat, vibration, and mechanical impact, and choosing a suitable enclosure rating. Option C. The brand name of the breakers. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option B. Boards must match the environment they are installed in. If the environment is harsh, you need suitable enclosure protection and construction so equipment remains safe and reliable. Review question 14. Why is clear labeling on a switchboard important? Option A. It is mainly for decoration. Option B. It helps identify circuits and devices quickly, reducing mistakes and improving safety during operation and maintenance. Option C. It only matters for office buildings. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option B. Good labeling reduces the chance of isolating the wrong circuit, energizing equipment unexpectedly, or misidentifying protective devices. It supports safe testing, fault finding, and emergency response. Review question 15. What is meant by prospective short-circuit current at a switchboard? Option A. The normal operating current of a lighting circuit. Option B. The fault current that could flow if a short circuit occurred at that point in the installation. Option C. The current drawn by a voltmeter. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option B. Prospective short-circuit current is the expected fault current available from the supply at a location. Switchboards, busbars, and switchgear must be rated to withstand and interrupt that current safely. Review question 16. Which statement about fault levels across an installation is generally correct? Option A. Fault current is usually highest near the supply and can reduce further downstream. Option B. Fault current is always the same everywhere. Option C. Fault current is always higher at the last socket outlet. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option A. As you move away from the supply, cable impedance increases, which usually reduces available fault current. That is why main boards often need higher fault ratings than downstream distribution boards. Review question 17. Which of the following is a common isolation device used on switchboards? Option A. A resistor. Option B. A main switch. Option C. A capacitor bank only. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option B. Main switches are common isolation devices. They provide a clear means to disconnect supply and support safe work by isolating circuits or the whole installation. Review question 18. Which set lists common isolation devices mentioned in this topic? Option A. Main switches, load break switches, circuit breakers used as isolators, fused isolators, lockable isolators, and disconnect links. Option B. Lamps, transformers and batteries. Option C. Motors, pulleys and belts. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option A. Switchboards use several types of isolation devices depending on application. The key point is they must allow safe disconnection and be suitable for the circuit's current and fault levels. Review question 19. What is a key requirement for an isolation device used for safe disconnection? Option A. It must be able to open only the neutral conductor. Option B. It must be able to fully open all active conductors of the circuit. Option C. It must only be operable with two hands. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option B. To make equipment safe to work on, you must remove the dangerous supply. Opening all active conductors prevents unexpected energization through an active still connected to the supply. Review question 20. Why is a clear on and off indication important for isolators on switchboards? Option A. So the switch looks modern. Option B. So workers can confirm the switching position quickly and reduce the chance of working on a live circuit by mistake. Option C. Because it increases the circuit current rating. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option B. A clear indication supports safe isolation procedures. If the position is ambiguous, people can make wrong assumptions, and that is how serious incidents happen. Review question 21. When is a lockable isolator especially important? Option A. When you want to stop someone else re-energizing the circuit while work is in progress. Option B. When you want to increase power factor. Option C. When the circuit has no load. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option A. Locking in the off position prevents accidental or unauthorized re-energization. It supports safe work control, especially on shared sites and multi-trade environments. Review question 22. Which statement best describes why isolation devices are a critical part of safe work? Option A. They reduce cable voltage drop. Option B. They allow circuits to be disconnected so work can be carried out safely and confidently. Option C. They replace the need for testing. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option B. Isolation devices provide the means to disconnect supply. But safe work still requires correct procedure, including proving dead with an approved tester. Isolation is necessary, but not the only step. Review question 23. What is the main reason switchboards must have barriers to prevent access to live parts? Option A. To reduce the size of the switchboard. Option B. To prevent accidental contact with live components during normal operation and maintenance. Option C. To make the switchboard harder to clean. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option B. Barriers and covers reduce the chance of electric shock and arc exposure. They help ensure only authorized, competent people can access live sections when required, under controlled conditions. Review question 24. What is meant by the switchboard must allow for operation and maintenance? Option A. There should be enough space and arrangement so devices can be operated, reset, tested, and serviced safely. Option B. The switchboard must be mounted at ceiling height. Option C. The switchboard must be hidden behind storage shelves. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option A. A board is not just installed and forgotten. People will operate it for years. Poor layout increases risk, slows fault finding, and can encourage unsafe shortcuts during maintenance. Review question 25. Why do boards need to consider metering requirements? Option A. Because meters reduce fault current. Option B. Because the supply authority may require space, ceiling points, and access for revenue metering. Option C. Because meters replace protective devices. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option B. Revenue metering often has specific requirements, including secure access, placement, and sometimes sealing. The board design must allow compliance without compromising electrical safety and access for electricians. Review question 26. Which statement about a MEN switchboard is correct? Option A. The MEN link should be hidden so nobody can find it. Option B. The MEN link and bars must be identifiable and accessible for inspection and maintenance. Option C. The MEN link should be installed at every distribution board. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option B. Because the MEN link is central to the earthing system, it must be clearly identified and accessible. Poor access leads to poor maintenance, missed corrosion, and unsafe earthing performance. Review question 27. Why can corrosion or loose terminations at the MEN board be especially dangerous? Option A. It makes lights brighter. Option B. It increases impedance in the earth fault loop, which can reduce fault current and delay protective device operation. Option C. It lowers the supply frequency. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option B. Protection relies on sufficient fault current to operate devices quickly. If the earthing path is compromised, disconnection may not occur within required times, increasing shock and fire risk. Review question 28. What does correct enclosure rating for conditions mainly help with? Option A. Preventing entry of moisture and dust that could damage insulation and cause tracking or faults. Option B. Increasing the turns ratio of transformers. Option C. Improving the sound quality or alarms. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option A. Dust and moisture can create leakage paths, corrosion, and overheating. A suitable enclosure helps keep the board safe and reliable for its environment, whether indoor, outdoor, or harsh areas. Review question 29. Which is a correct statement about distribution switchboards? Option A. They do not need fault rating because fault current is always zero there. Option B. They must still meet short circuit rating, enclosure, and wiring space requirements suitable for their location and supply. Option C. They never need protective devices. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option B. Even though fault current may be lower than at the main board, it is not none. The board and switchgear must still withstand faults and allow safe operation and maintenance. Review question 30. Why is proper segregation inside a board important? Option A. It makes the board heavier. Option B. It reduces the chance of accidental contact, cross-connection, and fault spread between sections. Option C. It increases voltage drop to protect loads. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option B. Segregation supports safe access and reduces the chance that a fault in one area damages another. It also helps prevent wiring mistakes and keeps conductors and devices organized for maintenance. Review question 31. Which option best describes a good safety principle for switchboard design? Option A. Make it as cramped as possible to save wall space. Option B. Provide enough space for wiring, heat dissipation, and safe maintenance. Option C. Put all devices behind unlabeled covers. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option B. Boards need space for correct bending radius, tidy terminations, heat dissipation, and future servicing. Crowding increases overheating risk and makes faults and unsafe conditions more likely. Review question 32. What is the main safety reason for ensuring the board has suitable ventilation where needed? Option A. To cool the building. Option B. To reduce heat buildup that can damage insulation and shorten device life. Option C. To make breakers trip faster. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option B. Heat is a major cause of insulation breakdown and equipment failure. If heat is not managed, you can get nuisance tripping, premature failure, and higher fire risk. Review question 33. What is the best reason for ensuring isolation devices are mechanically capable of being operated safely? Option A. So they look shiny. Option B. Because they must operate reliably under normal use, and failure during isolation can leave parts energized or create arcing. Option C. Because it reduces the cost of the installation. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option B. A worn, loose, or damaged mechanism can fail to open properly or can arc during operation. Reliable mechanical operation is part of electrical safety, not just convenience. Review question 34. Which statement best describes why isolation devices must have adequate current and fault ratings? Option A. Because the circuit current can exceed the device's safe capability, causing overheating or failure, especially during faults. Option B. Because ratings are only for paperwork. Option C. Because higher ratings reduce power factor. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option A. Devices must carry normal current without overheating and withstand fault conditions until protection operates. If underrated, the device can fail violently, increasing arc flash and fire risk. Review question 35. If a switchboard is installed in a dusty or damp area, what is the best approach? Option A. Ignore the environment because electricity is sealed inside wires. Option B. Choose an enclosure and installation method suitable for dust and moisture, and ensure ongoing protection against ingress. Option C. Remove all covers so it can air out. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option B. Dust and moisture can cause tracking, corrosion, and insulation breakdown. Correct enclosure selection and installation practice reduces risk and maintains compliance over time. Review question 36. Why are fault levels and prospective short-circuit current mentioned as switchboard requirements? Option A. Because they decide the paint color. Option B. Because the board frame, bus bars, and switchgear must withstand the maximum fault current long enough for protective devices to clear the fault. Option C. Because they only matter for DC systems. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option B. During a short circuit, currents can be extremely high and forces can be explosive. The board must survive without becoming a hazard, and protective devices must be able to interrupt safely. Review question 37. What is a practical reason for ensuring the earthing system at MEN boards is protected from mechanical damage? Option A. To make the cables harder to identify. Option B. Because damage to earthing conductors can break the fault path and compromise disconnection times. Option C. Because it makes the neutral smaller. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option B. Earthing conductors are part of the safety system. If they are damaged, fault current may not return effectively, protection may not operate, and exposed metal parts can remain dangerous. Review question 38. Which option best explains why the MEN link is described as the heart of the earthing system in this topic? Option A. Because it is the main point where earth and neutral are bonded, supporting the protective fault path. Option B. Because it improves transformer efficiency. Option C. Because it eliminates all voltage drop. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option A. The MEN link helps create a predictable, low-impedance return path for earth fault current. That is what helps protective devices disconnect quickly, keeping touch voltages low and reducing shock risk. Review question 39. Which is the best summary of why switchboards have strict requirements for location, access, fire protection, environment, metering, and fault levels? Option A. To make installations more expensive. Option B. To ensure safety, reliability, and compliance over the full life of the installation. Option C. To reduce the need for protective devices. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option B. Switchboards are central to distribution and protection. Good design and installation reduces shock and fire risk, improves fault performance, supports maintenance, and meets legal and standard requirements. That finishes the Topic 17 review. Listen again, choose an option, wait for the countdown, and check your understanding.